Hi everyone, my name is Jas Brooks, and today I'll be presenting Smell and Paste, work I did with my advisor Pedro Lopes at the University of Chicago. So let me tell you about my own experience in smell-based research. Over the last years, I produced several smell experiences as part of my PhD in chemical interfaces. Now, what do you imagine I did when I started them? You might be imagining I used some sort of canonical HCI time-saving method, such as low-fidelity prototyping, right? Well, I didn't. Instead, I had to go through the entire high-tech pipeline from the start, and that meant developing hardware, mixing fragrances, programming microcontrollers, all to try the experience once, and in the end find out that maybe the smells weren't right or that my early design decisions didn't pan out. Often, that meant I needed to reiterate, and that initial run already took me days to weeks to finish. Prototyping olfactory experiences ahead of working on a final form felt incredibly slow. For everyone here, that must sound pretty weird. After all, low-fidelity prototyping is so foundational to HCI, it appears in all early design cycles. Take, for example, the time-tested method of paper prototyping, one of the most important low-fidelity techniques used by virtually all UX and HCI practitioners. So what makes for a good low-fidelity prototyping technique? It's quick. Producing a prototype doesn't take long to whip up. It's approachable. Whether you're a novice or an expert, you can approach this technique without being intimidated. It's just paper and pencils. It's cheap. Anyone can source the materials. This also means that each iteration doesn't cost much of anything, so you can test out a bunch of ideas guilt-free. These qualities let anyone produce stand-ins to test ideas early before committing time and resources to a design decision. Following, today's talk is about lo-fi prototyping for olfactory experiences. Now, all my personal experiences made me wonder, how do other small experience experts prototype? To answer this, we interviewed experts from several backgrounds. The short answer is they don't lo-fi prototype. Instead, they jump straight to hi-fi or final projects. They reported taking anywhere from hours to months to get to this first iteration. This issue arises because there is no structured toolkit or method to help experts draft lo-fi prototypes. However, while they didn't lo-fi prototype, some participants did explore low-tech, low-fidelity products to create final experiences cheaply and quickly. Of these materials, we were inspired by this. So, what is that? Well, it's an old technology called a scratch-and-sniff sticker, a piece of paper covered in microscopic beads full of fragrance. By just scratching the surface, you release the fragrance from the capsules, allowing you to smell an odor, here, apple. Following, we took these findings and created Smell and Paste, a lo-fi prototyping toolkit for olfactory interfaces and experiences. The toolkit builds upon scratch-and-sniff stickers and relies on a cassette, like this one, to which a user can load smell tapes, like that. And as you advance the cassette scratches the tape for you and releases the odor. Apple. Now this cassette can be 3D printed or even just made from cardboard, as you see on the slides and that I'm holding right now. Both files and more are available at this link. Now let me show you how I use the kit to iterate a VR scene. There's a timer in the bottom right so we can measure how long this takes. Here I'm unsatisfied with a smell transition for a particular scene, and so I'm going to go ahead and modify that. I take my VR headset off, I put the cassette down, and I pull out the paper tape. Now you can see the sequence that I wasn't happy about. There's a scented sticker, and when you scratch it, you can release its odor. In our case, the cassette actually does that for you, and while you advance, a Velcro strip will scratch it, releasing its odors to your nose. Now, this is the transition that I wasn't super happy about. It actually had a fade out of a wet dirt scent to match me leaving the forest. And what I want to do is boost up the immersion of entering the cabin afterwards. So I take scissors and I start cutting a long triangle of a savory scent to represent the odor of the cabin. I remove the backing off the sticker, and then I simply just paste the sticker onto the paper tape. In a matter of seconds, voila, I was able to create a crossfade between the forest and cabin smells. And all that's left now is to rewind the tape, put on the VR headset, and give it a go. Let's pause here. I tested this sequence in about 1 minute and 20 seconds. That's quite a contrast to my earlier hi-fi iterations that took days. And while the underlying techniques are simple, you can still create expressive sequences and quickly produce alternative iterations. Here are several versions of the sequence that I made. This process takes minutes compared to the hours or months of the usual process identified in expert interviews. You can even multi-track sequences by stacking cassettes together. We then conducted studies to validate the toolkit. We designed a second study to explore smell and paste with a group of novices recruited from HCI class, at which we deployed the toolkit as an optional assignment. At the highest level, smell and paste enabled participants to rapidly draft many lo-fi prototypes of their olfactory experiences. It even allowed them to explore all key olfactory design features as defined by Emanuele Maggioni et al. This includes chemical, emotional, spatial, and temporal features in detail. Additionally, without being prompted to do so, participants paired smell and paste with established lo-fi prototyping strategies like paper prototyping, video prototyping, and even Wizard of Oz sessions. Participants not only prototyped sequences, but even composed new smells by combining scratch-and-sniff stickers together. Finally, the two participants with an engineering background found the toolkit easily customizable. In our last study, we engaged with experts from the interviews and asked them to experiment with the kit in their practice for 2 weeks. We recruited 2 experts from Study 1 for their extensive experience designing olfactory experiences for diverse audiences like children, people with disabilities, and elderly. Expert 1 decided to use the toolkits in a workshop with children, in which they trained each other's noses and then produced interactive smell stories. Expert 2 decided to test the toolkit to prototype olfactory movie experiences and tested the sequences on their spouse. From analyzing follow-up interviews, we found that experts were excited to integrate smell and paste into their work. Both were excited that prototyping resulted in a storable and shareable artifact that can be mailed. The cassette form factor let designers surprise their audience or user. Expert 2 found it useful that the cassette could 1, hide the sticker's visuals, and 2, that users didn't know what set was coming next, which is a typical problem for scratch-and-sniff cards, for which users can often smell ahead or smell odors before they're meant to be experienced. Finally, both experts found the physical affordances of the mechanical design to be intuitive. Expert 1 did not show the children our tutorials and reported they had no problem using it, saying the mechanical design is straightforward and communicates its functionality. Let me conclude. Our key contribution is smell and paste, a toolkit that enables low-fidelity, low-tech prototyping of olfactory experiences informed by expert interviews and user studies. The toolkit's materials keep iteration costs low, and like paper prototypes, smell and paste prototypes uses readily available materials, aka paper and scratch-and-sniff stickers. Its cassette can either be 3D printed or even made cheaper using cardboard, paper tubes, and a strip of Velcro. Thanks to this, creating, remixing, or discarding drafts is easy and inexpensive. Smell and paste enables very fast drafting of an odor sequence, taking minutes compared to the hours or months reported for hi-fi prototyping. In turn, designers can validate and test many design decisions super early on. And smell and paste is super simple and approachable, but also really expressive. But finally, I'm personally invested in being an active user of these new methods in my own research, because I see it as bridging 2 lines of my research on chemical interfaces, new input-output methods for HCI, and assistive/expressive technologies. Particularly thinking about how will we design these experiences once they become commonly available. So I'd like to thank my advisor Pedro Lopes for his collaboration, as well as my lab mates Alex Mzurski and Yudai Tanaka for their help putting together kits for my studies. I really appreciated it. Thanks for listening, and if you want to learn more about olfactory technologies, please check out our workshop, which is already in its 3rd edition and part of this year's CHI conference. See you!